Hi everyone. My name is Nunes. Am I audible? I think it's not on system. No, I think this is the. It's off. It's on. Yeah, it's on. Sorry about it. What? Hello. Yeah. I can hear you. How many of you all have heard of a service mesh? Oh, good amount of people. So today's talk is going to be about a popular service mesh called Istio, but I am going to be only talking about ambient mesh, which is the newer sort of service mesh. If to go to the history, right? Service meshes were traditionally sidecars, where each application in Kubernetes would run with a sidecar, and with that, it would increase like operational cost and all these things, right? So about me, I am a CNCF ambassador. I volunteer at Mumbai FOSS. I also run a hardware meetup in Mumbai. So if anyone wants to check out like a badge that I make, I can still pass it around. You can connect with me using that. It's an e-paper badge sort of thing that I built. I also do Lindy Hop, which is a dance form, and tech that I work with and interested in is hardware, Python, Go, Rust, and Home Labs is something that I keep working on. So back to the topic about service meshes, right? So before microservices, there was something called as a monolith, right? I'm pretty sure people have worked with Java. That was one of the most popular applications to have like a monolith. And Java still exists. It's not like it's a bad thing or it's a good thing, it's just an architectural pattern. So monoliths were like a one package sort of thing. If you had to update anything, you had to sort of run an entire upgrade, and like migrations were a pain. Everything was like quite slow, development, including development. So then we moved on to something called as microservices, right? In a microservice architecture, you have something like each part of your application would be divided into smaller services. So something like a cart, for example, would be a separate service. So what this would result in is something like, for example, if your cart service isn't working, your entire app wouldn't crash. Only that service, the cart service wouldn't work. So your users could still probably browse Amazon, but maybe not add to cart, which is all right for them, right? They're still getting traffic to their websites. But what happened with microservices is that managing them at scale became really hard, because each microservice, right, would be it would be a mixture, right? It would be Python, it could be Golang, it could be JavaScript, Node, whichever you prefer. Is this audible? Yeah. And with that, what happened was operational cost increased, right? You had to scale microservices. You had to also figure out, okay, if this particular service goes down, how do I find out what has happened? Logging was something that was not standardized, right? Nor was tracing, and even telemetry, right? So out of this, something called as a service mesh came out, and a service mesh is sort of a programmable interface, right? So what it gives you is a standard interface. So when you have microservices, everything is like just a tiny object in space, right? With a service mesh, initial architecture was sidecars, right? So you had, for each application, you would have like a sidecar, and that would do what is redirect all your traffic input and output to the sidecar. So you had something called as Envoy, which is like the smallest unit of a sidecar in Istio service mesh. And Envoy is a very high performant C++ proxy donated by Lyft to the CNCF organization. And so that was what was in use up till now, until ambient mesh. So ambient mesh is something of a open source contribution, and even the sidecar pattern is like all open source. The entire project is open source, and the main co-contributors for this, like at least till the final release, was Solar.io, where I work, and also Google. So huge thanks to both these companies for like sort of pushing out ambient. It's still in alpha status, so you do not want to run it in production, please don't. And don't blame me if you do. So yeah, ambient is still new. It's quite it's in alpha stage. Like not all CNIs, like the container networking interfaces, not all have support for ambient. Like I yesterday tried it on Talos, and I couldn't get it working, so I had to switch to Kind, which I think uses KindNet CNI or something like that, and it does work there. So the way the ambient mesh works, right, is there are two. So in the sidecar, it was just one sidecar, and it was one point of failure, right? But with ambient mesh, they split the L4 and the L7 capabilities. So your L4 proxy is like a TCP proxy, right? It does not do HTTP at all. Nothing related to the L7 layer is touched, and it is based on something called as a zero trust tunnel called Z tunnel. The way it works is that once you install ambient mesh, right, the entire node runs like something called as a Z tunnel as a daemon set. So each node has a Z tunnel. Rather than each application having one sidecar, you have each node that has a Z tunnel, and all communication is done via that using something called as IP tables and Geneve protocols. So these two are the I won't go into the technical details, but these two are used to redirect traffic transparently from your application to the L4 proxy. So I will show a short demo also if I have enough time. But yeah, so the L7 proxy is called a waypoint proxy. And with a waypoint proxy, what happens is you can do everything the L7 layer Istio that used to provide, right? So Istio provides a lot of things like authorization policies, traffic shaping, and all these things, which is very common for a service mesh, right? Because it aims to be like an interface for your application. So with a service mesh, your application does not need to actually implement things like rate limit, tracing, open telemetry, all these things. They are all done by the mesh. So your application is free to do only what the application requires you to do. So yeah, so this is how it works, the overview of ambient mesh. It's split into two things, the L4 proxy and the L7 proxy. And L4 is Z tunnel, L7 is waypoint. So this is how, if you have to visualize the Z tunnel, it looks like this. The applications communicate via Z tunnel from node to node. Right? If my app A wants to talk to app B, even if it's a local, if it's on the same node, it goes via Z tunnel. If it's on a different node, it goes to Z tunnel. And if you have something called as a waypoint proxy, the connection is upgraded to something called as Edgeborne protocol, which I'll show in the next slide. So this image is sort of like a very, I just made it yesterday in Canvas, so it's a little bit weird, but what it basically does is it impersonates the service. So if you notice there's like a spiffy thing there. I don't know if it's visible back there, but spiffy is like an identity management protocol, right? So each service on your service mesh has an identity map. So nobody can actually just call any service. You have to have like a valid identity to even communicate. So this is something called as zero trust, and the concept that Istio uses is called mutual TLS. So this part here, the MTLS part. So that's how your communication happens. And before, what used to happen is during the sidecar, right, you had to inject the sidecar with the app. So it was a very intrusive process. Your application had to support certain ports, certain methods to just get MTLS working out of the box. But with Z-tunnel, it's all transparent. Your app doesn't have to do anything. You just enable ambient, you add a label to your namespace, and all the pods in that namespace automatically get an upgrade to the MTLS. So yeah, so this is how the Z-tunnel does it. And if you do not have, for example, a waypoint, right, your traffic is still encrypted using MTLS via Z-tunnel to Z-tunnel. So all your traffic is transparently redirected to Z-tunnel rather than your service communicating directly to your another service. It goes via Z-tunnel. So I don't know if the image is perfectly visible at the back, but this is how the Edgeborne protocol looks. And there are like 3 modes of capture. Only when both the nodes are captured, it is like if there's a sidecar on the other end, and there is a normal Z-tunnel probably, or like just Z-tunnel to Z-tunnel and a waypoint, that is when your traffic gets upgraded, right? And this is how the Edgebone overlay works, and it's called the HTTP based overlay network encapsulation protocol. It's a very long name, but it basically, you can see the packet here, right? It's the IP, TCP, TLS, and it upgrades it to a connect protocol. So connect protocol, anyone knows what's a connect protocol? Any hands? Anyone uses proxies? Quid proxy? Nobody? So connect is basically a bidirectional tunnel in which you can sort of communicate. So mostly proxies like Squid proxy and all, they support the connect protocol. And yeah, that's it, the end, but I do have a small demo, 2 minutes. Yeah, so I will, it's better if I visualize it so it's more easy to understand. So yeah, so you can see, I'm not sure if you can see this, but you see there is no sidecar, right? There's just 1 out of 1 containers. If you look at the ready part, there's like just 1 out of 1 containers. And the Z tunnel is something that is like, runs on all the nodes as a daemon set. So hopefully that helps. But yeah, so you can see there's a Z tunnel running on each node and your Istio CNI as usual. To visualize this, let's just get it on of time. Maybe the demo cards are not helping today, but oh yeah. Wait. So let me just zoom in, and you can see the connections that are happening, right? You can see this lock symbol. So the application doesn't have any SSL TLS certificate. This is all MTLS via ZTunnel. So this is how the communication is secured from one service to the other, without actually having to, inject anything within your application. So it's very transparent. It just runs and you don't even know, your application isn't aware of it. It just runs on the node. So yeah, that's it for me. And yeah, any questions?
So in service mesh, earlier we used to have sidecar based. Then there is eBPF based like Cilium, and now we are learning about ZTunnel. Is it similar to Cilium, or how does the landscape look?
Yeah, so the way it works is, right, Istio has its own CNI, but so the question is basically there is something called as Cilium, which is an eBPF based CNI. Mostly it's a CNI. They also do TLS stuff and all that now, but they don't do MTLS. They don't do mutual TLS. They do TLS, but not the same. So the way it works is like Istio, right, supports Cilium as a CNI. So what you can do is you can run Istio and you can run Cilium as a CNI instead of Istio CNI. So you get the power of eBPF, you get the power of ZTunnel all in one cluster. So you don't need to actually just have like something like only Istio or only Cilium. You can use both together. I mean, right now it's an alpha stage, but eventually it does support Cilium as a CNI. So Cilium does everything, but only eBPF does. So you get both, like you get a network observability also very well, and you get your service mesh also done.
So what I could gather is
ZTunnel will help something on the security front. It can be used with Cilium as well.
Yeah. So it does identity very well, and it also does L4 layer stuff. So your L4 is handled by ZTunnel, whereas your L7 stuff like rate limiting, authorization policies and all, they all on the L7 there, right? So the L4 doesn't touch actually GitTogether. So you get identity as well as you get a CI for that.
Okay, thank you.
Any other questions?
I don't think so. If anyone has any more questions, just write outside.
Yeah, I'll be there for a very short time.